want to introduce a frequent speaker here in our group, Nick Kwiatkowski, who is from Michigan State Telecom, and he's going to introduce us to Portainer. Take it away.
All right. Thanks. Share the correct screen. All right. Hopefully you can see my screen there.
Yeah.
Excellent. All right. Well, anyway, I'm Nick Kwiatkowski. We're going to do an introduction to Portainer. So admittedly, I am not, I wouldn't say I'm an expert at Portainer by any means. I'm just a regular user. But I did want to introduce the application to folks who are in the CF world or just getting into containers or anything like that. So let's see here. Quick agenda. We're going to do just an introduction, like what is the application, all that type of stuff. We're going to go and review what is more a typical DevOps workflow, kind of building on one of my previous presentations I did earlier this year or late last year. We're going to go talk about the Portainer user interface and how to do a basic install. We're going to actually deploy a live container to some servers I got set up for this. We're going to talk about migrating from Docker Composer. So if you are using any type of containerization or any type of workflow where you're doing your own containers, typically you're going to be using Docker Compose. So this is how do you migrate from your application that you've built and is working on your desktop and deploy it into production. If you're in that environment, we're going to talk briefly about Docker Swarm and Kubernetes, and then talk about how you do some more efficient DevOps pipelines and integrations into Portainer. So about me, I'm the manager of the Unified Communications team and also the senior telecom engineer at Michigan State University. Under our purview is the phone system, cable television system, radio frequency, licensing, cellular, all that stuff. I'm also an adjunct professor at Michigan State University within the Communication Arts and Sciences College, specifically within the Media Information Department. I teach data networking, network security, and cloud computing. Within the International Value Users Group, I'm one of the program managers, where I help select telecom topics and all that type of stuff for the international conferences and their webinars. I'm an Apache Foundation member, committer, and PMC for Apache Flex, and Cold Fusion developer since looking back, I think somewhere in 1997 is when I started, somewhere in there. It might have been even a little bit earlier, a little bit later. I think Randy still has me beat by a little bit, and probably Charlie over here does too. But definitely been doing it for a few years. So what is Portainer? Portainer is a tool that can be used to manage on-site or cloud-based container environments. It provides an easy-to-use web-based front end to deploy, customize, and manage containers running on Docker, Docker Swarm, Kubernetes, and a whole bunch of cloud-based providers. So essentially, it is a common front end, a really generic front end, to allow you to manage containers regardless of where they are. The other nice thing about it too is it allows you to migrate applications from one environment to the other. So if you have an application that is currently deployed on, let's say, a Docker server that's sitting on-prem, you can easily deploy that to, let's say, Azure containers, or you can move it to Kubernetes. And really the configuration from your view of it is exactly the same. Now, mind you, there's going to be some back-end things you're going to have to do, like DNS changes, maybe some load balancer changes, that type of stuff. But the really hard stuff of having to translate a container environment, how do you define it, how much memory do you assign, what networks is it a part of, all that type of stuff, that hard stuff becomes all consistent, and allows you to have essentially one place where you can go monitor all those things, collect logs, even console into those servers to be able to, or into those containers to be able to see what's going on. So that's really the whole point of this this application, is really to be able to manage those containers. Now, there are some competitors in that same space. Red Hat has OpenShift. There are some other competitors that kind of do some similar stuff too. Some of them are very embedded in their own environment. For example, Red Hat OpenShift only allows you to work with Kubernetes, but it does have some ability to migrate applications or containers to the cloud and back and forth. There's also, like I said, there's other competitors to it as well, but Portainer is the one that I've been using for a lot of my stuff and my customer stuff. So Portainer really offers two versions. There's a community edition, which is open source. The neat thing with that, unlimited nodes, you're able to mix container types, but it does limit some features. So their community edition doesn't allow you to do role-based access control. What that means is if you have a login to the system, you can pretty much do everything. You can't limit it to, let's say, just somebody who can do audits of logs, or somebody who can only deploy containers, or somebody who can only update versions on tags or things like that. They also limit to a degree some integration with some of the popular authentication systems. You can set up your own connector to Active Directory, any type of OAuth-based system, whether that's Keycloak or OAuth or Okta or any of those types of systems. But they do have, if you have the business edition, they automate some of that for you. One thing that they do limit in the community edition is the ability to automate updates of containers. So in the business edition, one of the really neat features is it can go and expose webhook URLs. You can go plug that into, let's say, Docker Hub, or into whatever Docker repository you might have, or container repository you might have, registry, sorry. It can actually essentially tickle a URL in your Portainer environment, and it'll automatically update and load the latest version. It can also do change control and all that type of stuff too. Within the community edition, they have the same functionality, except it can't be automated. So you have to log into their UI, and then you would do updates by clicking on some buttons. Really, it takes just a few seconds. It's just not automated. The community edition does not have the ability to audit authentication and activity logs. And it also doesn't have the ability to do auto deployment of Kubernetes-based systems, either on cloud or on-prem. So it has the business edition has the ability to essentially log into a raw host, install Kubernetes, get everything set up, and ingest that environment into the Portainer environment, which saves you quite a few steps. You don't have to do it by hand. If you're in the Docker environment, you actually can do that pretty easily just with a few commands. But Kubernetes is definitely a beast to get set up if you do it on your own. That business edition, like I mentioned, you do purchase nodes based off of usage. So if you're only doing 3 nodes, they have a free license available for you. You do have to renew it once a year, but literally you go into their portal, you say, yep, I want a three node free license, and you have all the features above. You're just limited to only 3 nodes. And when we say nodes, that's a container host, so that you can really launch as many applications as you want on those, or containers as you want on those. It's just physical CPU essentially is you're limited to 3 of those. Anything more than that does require a paid subscription. A lot of their paid subscriptions also include support, installation support. They do have discounts for students and home users, and they also have discounts available for educational users as well. Like I mentioned, Portainer is a pretty consistent front end for your container environments. So it allows you to take your Docker images and deploy them. You can modify environment settings, deploy updates, all that type of stuff. It's very easy to customize and tweak settings, check logs, log into containers for troubleshooting, all that type of stuff. You can migrate containers between Docker to Swarm to Kubernetes-based systems. That is one nice thing, is there's no vendor lock-in on that. I can literally go and, in fact, some of my container hosts that I've got in my sample environment here, some of them are running locally on my machine, some of them are running in AWS. It doesn't care, as long as it can do TCP connections back and forth. It's able to talk in those and manage those servers. Portainer itself actually runs on either Docker or Kubernetes. So in order to get the entire environment set up, you do need to have Docker or Kubernetes set up already and running, but then you manage it, and then it'll help you. Essentially, they even walk you through doing that initial install too. It's like 2 commands. So before we get any further, are there any questions as far as what it is, 1,000-foot view?
1,000-foot view, Nick. Why? How did you run across this? Or what was the driving force? I imagine because of simplicity, but go ahead and answer that for me.
Yeah, driving force for me is in my environment in the office, we now have probably a dozen to a dozen and a half different Docker-based servers running different applications, whether they're API systems, whether they're part of the phone system, whether they're part of some of our management tools. A lot of our vendors are moving to providing Docker images for our applications. So the way we used to do it before is you set up a basic, let's say Red Hat or Rocky Linux or something Linux install. You install Docker, and then you can run that container. Well, that's great. The problem is, now you've got dozens of servers that you have to log into, and every time you want to do an update, you have to, do CLI commands, all that type of stuff. You want to collect logs, you have to go in there, do CLI commands, which for me, I'm very familiar and very happy with Linux. That's totally cool. But when I start talking about some of my employees and some of the folks on my team, now they're like, well, which server is it? How do I see what's running where? How do I collect logs? And it becomes, pretty laborious when you start getting more and more Docker hosts out there. So that's 1,000-foot view. That's why we needed an application like this. The university itself is also looking for a similar tool. I believe they're going down the direction of OpenShift, but they're very happy with like that Kubernetes only environment, which is why they're choosing that. So kind of building on my previous presentation that I've done on Docker, like on containerization and using Docker and all that type of stuff, where a lot of you spend your time and where I spent a lot of my presentation in the past is how do we do that developer ecosystem? We write some code, we do tests, we commit to our version control, we do some tests, and we keep on going back and forth in this environment here, until we have a product or a feature or something like that we're good to go. That usually is going to involve a tool called Docker Desktop. So the Docker company makes a tool that installs on Windows or on Mac, and it allows you to essentially do stuff with Docker. It has a tool, a plugin called Docker Compose that makes setting up like multiple Docker images or containers that are all kind of tied together very easy. You do a YML document, and you keep on doing that. GitHub has some great integrations with all this as well. But when you're at the point that you want to submit a release, or you say, hey, this application is good to go, we want to go and push that into production, this is where we start talking about we have a DevOps environment or DevOps pipeline. So we say, yes, we're good to release. From our developer ecosystem, we go and mark a release. If you're using GitHub, typically that would be you'd go into the GitHub repository, and then there's the option to make a release. And there's some workflow things you can do to create a container image. A container image, essentially, it takes your code and your environment that you've built in your developer ecosystem. So that might be Lucee, that might be ACF, that would be with Tomcat, that would be on a Linux image. All that stuff takes all your code, copies it into there, and makes essentially an image. So think of that that DevOps environment or that container image as like a hard drive image. It's a snapshot. In the VM world, we call that an OVA or an HDX. Essentially, it's a hard drive image of what is happening with your environment. So we create that container environment. We typically do that in the Docker Hub or within GitHub or some sort of CI/CD type of environment where wherever you're storing your code, a lot of those can create that container image. And then we push that image to a registry. A registry essentially is just a website or essentially a host that hosts those images of your application. Some of them can be private, some of them can be public. In the open source world, a lot of people use Docker Hub. That's kind of the center of the ecosystem for a lot of these container images, but there's a lot of places that do their own private ones as well. Yeah. So Charlie Earhart said Docker Desktop has been available for Linux for a couple of years as well. It is, yes. I would say, and as you noted on there, can be somewhat unnecessary, but it does have quite a few tools in there. So it is, yeah, Windows, Mac OS, and Linux. But yeah. But in general, you're going to, once you mark that release, you're going to create that container image. You're going to push it to a registry. You're then going to deploy it on some sort of container engine of some kind. So that container engine could be Docker, it could be Kubernetes, it could be a cloud provider too. AWS has their version of a container image, EKS, ECS, running Fargate, for example. They have just a whole ton of those. Azure has their versions of that as well. Under the hood, the Azure stuff is mostly running Kubernetes. Google 100% runs Kubernetes under the hood for them because they're the ones who kind of created it, and so forth. But yeah, so then after you deploy your application on a container engine of some kind, then you would activate it, test your deployment, so forth. Typically, instead of just going right to release, you would also have a some sort of environment for test, for, typically your dev environment is going to be in this ecosystem over here for fast iteration. You're typically going to have a test environment, which really does the exact same workflow. Really the difference between test and production in most cases is going to be test is going to typically deploy those images. And then once you say an image is good to go, pass all your tests, all that type of stuff, you say, yep, we're also going to do this exact same release on prod or to my users or that type of stuff. So 1,000-foot view, this is how this kind of comes together. And where we're really talking about in the Portainer environment is going to be this deploy onto a container image or a container engine, and then activate and test that deployment. That's really what we're talking about in this environment, in this setup here. All the other stuff we talked again about in previous presentations. So again, in a typical developer environment, you're going to use your IDE or your code editor to develop your application. You would use a tool like Docker Desktop to build local versions of your app, test, iterate code, debug. Docker Desktop will allow for real-time updates and updates of code to the container you're running. So you can, with a lot of the setups, and again, the way that I've presented it before, you can go and make changes, live changes to your CFML pages, and it shows up in real time as if it's on your file system using some magic that they have in Docker Desktop. You'd be able to commit versions of you would then commit versions of your code to source repository like GitHub, GitLab, Bitbucket, really whatever you have. You would then have some sort of test suite to make sure that whatever you're committing is correct and works. Eventually, you'd mark a version as complete and ready to deploy. Sometimes developers push their own versions up to image repositories, but it's more common to see the automated builds at this point. Even GitHub in their automated or in their free tier for your repositories will allow you to essentially spin up a copy of Docker, build your image, and store it somewhere. When a version is ready to move up to that DevOps chain, again, an image of the app is created. This can be done by the VCS, very typically like GitHub or something like that, or using a separate tool. Like I said, most VCSs, version control systems, have scripting where they will take your Docker file, read it, build the image in the way that you specified, and so forth. When the image is then created, it's then pushed up to an image registry. It could be a private registry that requires a login password or private network access, or it could be a public one like Docker Hub. Like I said, in the open source world, you typically are going to see stuff in Docker Hub. Not always, but that's usually where you're going to see things. The image registry would keep track of versions of an image that were published using a system known as tags. If it's private registry, you would limit access, of course. And then many image registries allow for automation in that when an image is published to it or updated, it can let downstream tools know using like webhooks or web pushes or things like that. So now we can deploy your application into production. You could be using a web tool like Amazon Web Services, EKS or ECS or Lightsail. GCP, so Google Cloud Platform, also has their version of containerization. Azure has container services. Lots of hosts out there like Linode, Oracle, other ones also offer some sort of container services as well. You could also be using a command line tool like Docker Compose, Docker, or Kubernetes on your own local machines, or you could be using a container management tool like I mentioned, Red Hat OpenShift, Portainer, Rancher, Tanzu. Like I said, there's a whole variety of these things. Tanzu is an interesting one. It was a lot more interesting about a year ago. That is a tool run by VMware or created by VMware or part of the vCenter suite or the vSphere suite. That one was kind of neat because, again, you had a very similar setup like Portainer, except it deployed them naturally in your VMware environments. Unfortunately, VMware decided to, well, when they got purchased by Broadcom, did some interesting thing with licensing, and so Tanzu has kind of fallen out of favor for a lot of folks, particularly for on-prem deployments. Deploying typically takes container image, pairs it with environmental settings like networking requirements, container dependencies, environment variables, secrets, all that type of stuff, and then runs it on some sort of compute. Again, 1,000-foot view, this is what that workflow is. So without further ado, let's show you what Portainer UI, what Portainer really looks like. So let me go and pull up a screen over here. So when you log into Portainer, this is essentially the screen that you're going to see. Right here, I actually have 3 servers. Actually, it's 4 servers set up right now. So I've got CFUG Demo 1, CFUG Demo 2, and I have a Swarm server as well. So when I'm in here, I can start to jump into one of these servers that is running some containers. So if I go into server number 1, this is what you kind of see here. So you'll see that this particular server has 2 CPU, 1.8 gigs of RAM. It is running Docker standalone 27.3.1. I didn't expose GPU data, any of that type of stuff. On this particular server, I've got 0 stacks, 1 container, 4 images on the server, which take up about a gig worth of space, 1 volume, and 3 networks. Now, if you're not really heavy in the Docker space, these probably mean absolutely nothing to you, or I should say container space. The nice thing is, again, whether you're using Docker Swarm, Kubernetes, or Docker standalone, they make the terminology identical across all the different setups. The only difference is if you're in an environment that supports, let's say, something like Docker Swarm or Kubernetes, you're also going to get the option for something called services. So I'll get into that in just a little bit. So in here, stacks. So stacks are essentially think of it as well, I'll start off here. We've got networks. So networks are pretty obvious. You can do your own VLANing or your own internal networks on that host itself. Pretty easy. You can go and set up essentially so applications can talk to one or multiple networks. So let's say you can create a database network, for example, where you can have multiple database servers and you have applications that can talk to that database network, but the public can't get access to it. So in order to get access to that database network, you need to be talking to a container that essentially is allowed access to that network. Volumes are persistent hard drive images. So think of a shared disk in an environment, or like an S3 bucket, where regardless of what happens to your containers, whatever happens to your applications or whatever, if you restart them, if you delete them or whatever, that storage stays, it persists. Generally, the way that containers work is a container's normal hard drive lives as long as that container is running. As soon as that hard drive, or as soon as that container is shut down, that hard drive that exists with it goes away, unless you mount, or unless you say anything in this folder I want to keep. So for example, in a lot of my images, things like security certificates or user uploads or things like that, I want to persist. So those would have their own volumes. Images are essentially those snapshots of hard drives. So the way that vendors, or the way that the open source community essentially give you access to run this code, is they give you that hard drive image. You would then run a copy of that image, which then is that running application. So right now you'll see I've got a few images over here, which happens to be the Portainer updater, which essentially is what Portainer uses to update itself. I'm running the Enterprise Edition or the Business Edition, the latest. I have a Community Edition of 21.2, and I have a Enterprise Edition of 21.2 on this machine over here. And in theory, I could go and just run those, and then they would just run. Everything to boot the machine, all that stuff is all baked into those images. Containers are the running machines. If you think of any type of virtual machines, these are like essentially the actual like running copy of Linux or Windows or whatever you might have, bundled in with all your software. So yeah, so Portainer over here, I've got a whole bunch of different options over here. It's got an ID, which really doesn't mean anything. It's got an internal IP address. It says that this particular version here has been running for about 3 hours. It was created, it has a start time. Access control, because I am on the Business Edition on this machine right here, or in this installation, I can actually say I want administrators to run this. I can say that certain users or certain levels of users can access this container as far as the administration of it. The image of it over here, container details. So this is all sorts of information as far as what ports I'm exposing. So like, how are people accessing it? What entry point, and a bunch of other data here about the environment and all that type of stuff. There's a restart policy on here saying that if this container fails for some reason, so let's say it crashes or something like that, it's always going to restart it. Volumes, we're saving some data here as far as that, and then I can say what networks is this going to be connected to. So in this dashboard over here, I don't have any what they call stacks. So a stack essentially is a group of containers. So let's say Randy goes and builds a really cool application that accepts credit cards from a group of, let's say, alumni associations or something like that. So he builds this really cool application. And in there, he's going to have a Cold Fusion server or a Lucee server. He's going to have a database of some kind. He's probably going to have a web front end to secure the things, to provide SSL, and maybe something else. All of those things now you can go and group together as a stack. So if you are developing this on your own machine, typically you would put that stack together using Docker Compose. So Docker Compose is essentially a document that allows you to pull together a whole bunch of settings. So this over here, for example, is a Docker Compose file. And you can go and define, say, hey, I'm going to be running this particular image. It depends on something. I've got some environment settings. I've got some labels on here. I've got a database. I'm going to set my root password to be SA password because that is awesome. I'm going to go persist the data on there. I'm exposing some ports and so forth. We have a bunch of different mounts. So this definition file here is what you would typically run on your local machine. So that essentially a stack is the exact same idea. You can go and combine a whole bunch of Docker containers, those images, tie them together, do a central place where you can do that configuration, and then it just kind of loads everything together. So you can go and watch the health and the networking and all that type of stuff of your application in totality, as opposed to each individual server that might be running. Yeah, going through the rest of this over here in the host and areas, OS information, kernel information, probably stuff you really don't need to look at a whole lot, but it is here. Registries, I mentioned earlier that you can go and instead of having your images, those hard drive images, located on Docker Hub, you can actually locate them on local registries or ones that require usernames and passwords and all that type of stuff. If you ever had to do anything with the registries on the command line, they're kind of a pain in the rear. What's nice about this is you can say, hey, I want to pull in my images from AWS ECR, the Elastic Container Registry, where you can give it a name, you give it a registry URL, authentication, so your AWS access key, secret key, what region you're in, and then you can start pulling images from that as well. Quay is another one, ProGet, Azure, of course, GitLab has theirs, GitHub has a container registry, or you can do your own if you have something local on your machine or on your environment by itself. At MSU, we tend to use a lot of GitHub, a local GitHub repository, which is kind of nice. So I can go and bake in a username and personal access token so that my copy of Portainer knows how to pull down those images without a whole lot of back and forth. So before we go much further, are there any more questions about this or like how the environment is set up or things like that?
One question, Nick. You said
Yep.
the database is also a container or inside of a container, which is inside of the stack. And
Yes.
what database are you using in this example? I don't think you mentioned it or I missed it.
I
Sorry.
haven't loaded any containers really for that yet, but for the example I'll be showing, it's going to be MariaDB, which is essentially MySQL. So
Okay.
Maria is a fork of MySQL, but they have containers that you could be doing like SQL Server. They have all those. So in the container world or like the Docker world or whatever you might want to say, it is very it is heavily encouraged that every service has its own or everything that your application does sits in its own container. So you don't have your database sitting next to your like Cold Fusion server. You don't have your web server or your web front end sitting in the same container as your Cold Fusion server and so forth. All of them are completely separate. The nice thing about that is like if you have to do a database update, for example, you update that container. There's no possible way it's going to screw up your Cold Fusion server. If you want to, it also helps limit CVEs. So like if there are vulnerabilities and things like that, because you have less stuff in there. The other side effect of that too is if somebody manages to hack into your Cold Fusion server because of bad code or whatever it might be, or a vulnerability, the most they can get access to is your Cold Fusion server itself. They can't actually get direct access to the database to be able to pull down all the files or things like that. So a couple different things, but the other side effect of that too is now you can also move your database easily and cleanly from one server to another and so forth. So that's kind of how everything kind of comes together in the container world.
One other question.
Mhm.
So if the database is in its own container, which sits inside of the stack,
Yep.
I'm thinking from, let me see which question I want to go with first. I assume Apache's in its own container as well.
Yeah. Yep. In a typical environment, yes, you would have like an Apache, some sort of front end. So that'd be Nginx, that could be Apache, that could be something like that. For a lot of my front end stuff, I tend to do a container-aware front end known as Traffic, TRAEFIK. And you'll see an example of that here in just a minute. But what's nice about that is in addition to being a typical Nginx front end, it also has a whole bunch of plugins to do things like authentication. It can help automate things like pulling down security certificates and keeping them up to date and all that type of stuff too.
All right. Last question, so I can let you get back to the presentation. Since Charlie's in the room, what I'm seeing here is if I'm dealing with ACF, I'm seeing a license issue. When you're dealing with Lucee, I don't see any license issues. You know what I mean? It depends on how many containers or,
So,
you know what I mean?
yeah, so from a technical standpoint, loading ACF into this is pretty easy. What you would do is you can either embed in, and I'll show, let's see here, if I show Portainer, because I think it's got some environment variables. There's some environment variables over here. Like I can go and bake in an ACF key into here. There's other ways that you can distribute those keys as well. Using I think it's called the Cold Fusion Manager, I like to say. But you can deploy ACF in Portainer just like anything else. Now, as far as the licensing and how you number of CPUs you have to get and all that type of stuff, and licensing versions and all that type of stuff, I admittedly am not an expert on that, so that is something I would defer over to Charlie for that. So he said, yes, you do need to license it. You can use the developer edition for free. If you don't enter a license key, that's what you're going to have. So yes, you can do it. And like I said, from a technical standpoint, the way you would deploy it for Lucee versus ACF is exactly the same way. The difference would be if you have a licensed version, you would have to embed that license key somehow in however you build that. So there's a variety of different ways you can do that. And like I said, I'm not an expert on that, so I'm not necessarily going to talk about that piece.
Thanks.
Mm-hmm. So other quick things I wanted to mention in here as well. Let's see here. Yes. Yeah. Okay. So yeah, you would pass an environment key variable for passing that license key to the container. So yeah. So you have the ability to load in users. You can tie those users to external authentication if you want. Tying in authentication for my production environment, we've tied it in to Okta, which is the university's choice of how they do user authentication. So a user logging into Portainer would get an Okta login. They do their authentication there, and then away you go. So pretty easy. You can set up teams. So a team can get access to certain containers or certain stacks or certain hosts, and you can define that based off of roles. And they also have roles as well. So a help desk user, for example, would get read-only access to the entire environment. You can have operators, edge administrators, standard users, read-only users, and so forth. And you can set up additional roles if you want to as well. So there's a lot of flexibility that's available in the business edition or the enterprise edition. Again, you would not have access to these different roles or the teams if you are in the community edition. Environmental related stuff, again, you can set up different environments. These would be hosts that are running things with that. So I've got, again, 2 servers preloaded on here. I've got a swarm environment. I can go and group those into different types of groups that you can do. I can put tags on those, all that type of stuff. Registries, if I want to have a registry available for all of my users and all of my hosts, I can set them up here. And we also do have authentication and activity logs that show where I'm at, what I'm doing, all that type of stuff. So if you do have more secured environments where you need to check for different types of log activities or things like that, you can do that. And then there's also notifications if I change. Essentially, this is more activity logs and all that stuff. As far as the built-in authentication, mentioned all this earlier. You can set up complexity for password rules, all that type of stuff. Shared credentials to get into different like Git repositories, all that type of stuff. They do also have the concept of edge compute as well, and I'll touch on that just a little bit later. So this is the basic environment that we have here, and we'll actually dive into that a little bit more. So as far as how things communicate and all that type of stuff, really 1,000-foot view. Again, you've got your Portainer server, which you have a user log into and all that type of stuff. For the most case, I've always done Portainer agents. Essentially what a Portainer agent is, it's a Docker container, or I should say a container that you load into an environment. It gets access to the how that container or that environment is configured and things like that. And then Portainer essentially gets a login into that agent and then can manage things. So you'll see, it can do Kubernetes, Swarm, standalone, Microsoft Azure, and those are all outbound connections to those containers. If you're an environment where you have agents, let's say in other sides of firewalls or things like that, and you don't want to open up these agents or these container environments to be able to talk to Portainer, they also have what they call edge agents. Essentially, that would also be a container that you load into your environment. So again, Docker standalone, Swarm, Kubernetes, and it does an outbound connection and logs into your Portainer server. The disadvantage of that is sometimes some actions are a little bit delayed, but once it's set up, everything is pretty much the same. So this would be outside communications going inbound to the Docker Portainer server, where the regular Portainer agents are outbound from it to the agents. It's just a matter of what's best for your environment. Really, they end up, generally doing the same thing. So like I mentioned, installing Portainer requires a container service of some kind. If you're on-prem, I highly recommend Rocky Linux, although most Linux distributions work just fine. I know people that use it with Ubuntu. I know people that use it with Red Hat Linux. There's SUSE Linux works just as fine as well. As long as you can get Docker to work, it is not a problem. You want to make sure you install Docker using the official docs. So docs.docker.com/engine/install. You would say what distribution that you use, and then follow the directions. For Rocky, if you use just a really base Rocky install, you do the base server, install nothing else, and then you execute these commands right here. So yum configure manager, you're going to essentially add the repository of the Docker from the Docker folks. You then say you're then going to install Docker CE, the CLI, container IO, and so forth. You start Docker, and then you enable it so it automatically starts when the server restarts. Once you've done that, to actually install Portainer, you have to create a volume. So Docker volume create Portainer data. That essentially is the data that is stored for the server itself. And then you would enter in this command right here, the Docker run, and then I'm not going to bore you with what it is over here, but essentially you're mapping port 9443, and it's going to grab from Docker Hub the, let's see here, the Portainer CE 221.1. And then once you have that, and it takes about 30 seconds or so for it to pull everything down and then start running, you would then go to your machine, port 9443 with HTTPS, and you can log in and start to configure your environments. That's about it. So once you have Docker installed, it's really 2 commands to get the thing running. As you want to onboard additional machines, it'll actually help you and give you the commands every single time to do that. So let's go and deploy a container. So again, I've got a application here. Let me go and pull that up. GitHub. And I'm going to show off, let's see here, CFUG today. So this is a really basic application. By the way, I do have a Docker Compose on here if you want to see what's in there. Literally, it is a single container. Could be single container. In that container, I've got a Docker file, which essentially is based off of Lucee. In my application itself, I've got an application CFC, which is really boring. This .name equals today. I'm not doing any session management. I'm not doing anything. Literally, this is just a one-hit application. This application here takes an old BBS application that I used to have that when people logged in said, hey, this is what happens today, or this is what happened today. and it displays birthdays and special events. The files that I have in here, literally I copied from my old OS2 deployment here for October, is this file right here. Essentially, I'm just parsing this thing, and it has a bunch of birthdays and special events that happen on certain days. It is a very, very simple Cold Fusion application, but it is a Cold Fusion application nevertheless. Not fancy at all. So we're going to go and deploy that, and I'm going to deploy that on CF server number 2. So CFUG demo 2. I'm going to go connect to the server, and I'm going to go to the container section because I'm just deploying a single application. I'm not depending on a database. I'm not depending on a web front end or anything like that. So I'm going to go and add a container. So from here, I'm going to call this thing just today because that's all it is. And I am going to grab my image that exists out there on Docker Hub. It has the Docker Hub tag of Q2/CFUG Docker today, and I'm going to grab latest, TEST. There's an option here to always pull down the image. I can do that webhook thing, and I'll talk about that a little bit later. So network port configurations. What ports do I want to open up to the world so people can connect to this? So I'm going to say I want my CF Docker today, CFUG Docker today application. I want the internal port of 8888 to be mapped so people who go to the URL for this, :8888, will be able to access my application. Since I am running the business edition, I can say I want my administrators to run this, or I can say different access controls. And then there's a whole bunch of advanced settings that I could set here. Do I want logging? Do I want those logs to go somewhere? If I have volumes, if I have special network settings that I want, environmental settings, labels, restart policies, all this other type of stuff, if I want all that to happen. In my case here, I am not going to set anything special, so I'm just going to go deploy this container. So when I hit deploy, what Portainer is doing is it's instructing server number 2 to go pull down that image from Docker Hub, and then it's going to go start running it. And it's already there. So you'll see a couple of things in this list of containers. I've got the image. It says that it's currently the current version. By the way, it automatically checks to see when it's if it's the latest, what the IP address is locally, what ports, who owns it. I can go and pull the logs. I can inspect the server. I can go and log into that server, all that type of stuff. So when I go in here, I can then, stop it. I can kill it, restart it, pause it, recreate. So essentially it destroys whatever hard drive image was there and then reloads it from scratch and all that type of stuff. So if I want to look at the logs on this particular server, I can just click on the logs button here, and you can see this is a very typical Lucee setup running on Tomcat. Does its thing over here, and if I scroll down to the bottom, it took about 5.5 seconds for this thing to launch. All right, that's cool. I can go and inspect it. So this here would show different environment variables, all that type of stuff on there. I could pull some statistics. What's the memory usage of this particular server running, I/O use, CPU use, all that type of stuff. And what's neat about Portainer is this is not data you would typically get from the command line. You can pull some of this, but it's a little bit harder. And it shows the processes running on there and all that type of stuff. And then also I can do a console. So if I want to log into the server, I can go log into this thing here and I can see, this is a regular bash command prompt running Linux. So I can do anything with that. So let's go and just prove that this is actually running. So I've got CFUG to CFUG, let's see, to suroot.com. Oh, port, forgot here, and it's port 8888. And here's that really basic application. So apparently on October 8th was Jesse Jackson's birthday, or is Jesse Jackson's birthday, Canadian Thanksgiving Day. There was an earthquake of some kind. So yeah, application is running. It's doing really basic things. If I made it fancier, you could go and flip between different days, whatever. The container runs. CF is, or Lucee is pushing back live data. So that is deploying a really basic application. Like I said, this has no dependencies. It doesn't do anything special. I don't think I have anything logged on here as well as far as that. What's neat too is in this log view over here, it automatically refreshes, shows when logs happened, all that type of stuff. I can search the logs as well, filter, all that. So again, fairly cool stuff. It does work. So any questions at this point?
It's broken. I can't get to it.
That is because it is behind a firewall.
That's, I assume, I was gonna mess around with it. See if I can break it.
See if you can break it, huh? Well, if you want to, let's see here. If you want to go and connect to this one here, I can go and open this up really quick. If you go to port 8888, if you do that URL, that should load, I believe. So, like I said, really basic stuff here. So this is the container.
It worked. I guess I'll believe you this time.
Yeah. Yeah. Okay. So, and then if I will, get bored with that container, if I don't want to use it anymore, I can go hit remove, and it'll go and remove it from there. So let's talk about. Actually, let me go and load a new server into that environment as well. So when I'm back at my home over here, you'll see CFUG demo 1, demo 2. I actually have a third Docker server that is ready to be loaded. Sitting out there, and I'm going to show really quick how that would happen. So this is probably something that you'd be doing just to show how easy this really is. So in my environments, I can say I want to add a new environment, and I've got a Docker standalone. And it's got a little wizard here and says, hey, if you're doing agent, this is the command that you have to copy in. If you're doing API, socket connections, the edges and all that type of stuff, I'm just doing a standard agent. So I can say, this is what I'm going to run. I'm going to go connect to one of my servers, which happens to be CFUG 3. And I can go and run that command. You'll see right here, it's downloading everything to do with that application, that agent, and now it's running. So server number 3, I totally forgot to write down what IP address it is, but that's fine. I can go find that. So CFUG demo 3 is the name of this one here. The IP address of that one, let me go pull that up here really quick, is, nope, not that one. Here we go. It is going to be 172.31.126, and that is port 9001. And I can go connect. And if I go to my environments, I now see server number 3 or server number 3 there. Server number 3 is here, and I can go and deploy containers and stacks and all that type of stuff, create volumes on here as well. So that's really all there is to onboard these things. The only thing to note is if you already have images or containers running on a server when you onboard them, you won't be able to do much with them until you have Portainer actually manage them. So what that means is if you had, let's say, 4 or 5 containers running before, and then you go and say, Portainer, I want you to start managing the server, until you refresh those containers, Portainer will really only be able to pull back the logs. It won't be able to do a whole lot else. And I'll let you know about that. All right. So that's all there is with this. So I can log out of the server. Hopefully I won't need to get in there again. All right, so that was a container. So let's say we have a composer-based setup. So we had a application that was fairly complicated. So I've got, if you remember one of my earlier demos that I did, again, about a year ago, I did a little stock ticker application. That, again, is this guy right here. There's a CFUG Docker project. If I pull that up on GitHub, and I pull that up if I can find it somewhere. CFUG Docker project. Again, haven't touched this in a year, but this one has a database, it has a front end, it has a web proxy. This one here, by the way, I also have a workflow so that if I make a change in GitHub over here, and I go and create a new version, so I go to tags, I can go and create a new tag. Say releases, draft a new release. I can make a new release. It'll actually go and take a snapshot of my Docker or of my GitHub repository and then run that Docker, create that Docker image for me. There's one already out there, so that's what I'm going to be using. But what this particular application is, and by the way, it has some secrets. It's got a database. It's got a bunch of stuff. It's got a really basic page over here that's running, I think, data tables and shows a stock ticker, and that refreshes every few seconds, I believe. JavaScript in here, whole bunch of code, gobbledygook, you know, that type of stuff. But yeah, this thing here looks like it refreshes every few seconds. Once it's actually running. Has a REST component, so ORM, and some REST on here, where we're generating some fake stock. It does a Git, all that stuff. So here it is. Then the important thing again is it also has a web front end. So this proxy, we're using traffic for that. And essentially it's going to go create a self-signed SSL certificate and get everything going for us. So I'm going to go to, what server am I going to? I can do server number, let's do server number 2 again. That's fine. I'm going to go and turn off this today container just so I don't have anything that conflicts. I don't think it will, but this is a demo, so I'm going to start clean. So I'm going to go to stacks. Again, a stack is a set of containers that are supposed to kind of run in unison. So I'm going to go hit add stack, and I can go give this thing a name. And we're going to name this, what did I want to name it? Demo app? Now we can call it CF stock demo. Okay, and this is going to be deployed using essentially the same thing as Docker Compose. I could upload that Docker Compose file. It can go pull it down from a repository, or I could do a completely custom template. When I do a custom template, essentially I'm going to be not using Docker Compose. I'm going to go and do things by hand. But what's really neat about Portainer is I can take that Docker Compose file, one that already existed before. I'm just going to copy and paste this into here and literally paste in here. So I've got my front end. It's going to pull this from the CF Docker project. Depends on the database. I'm going to enable the Lucee admin. I'm setting the admin password to admin password because that is super awesome. I do need to set the what database server I would be using. So in my case here, I'm doing CF stock demo -db-1. That refers to my MariaDB database on here. I've got a schema, I've got a user, I've got a password, some stuff for traffic over here that's essentially going to go and create that SSL cert and all that stuff and do the routing for me. I'm setting up a MariaDB running version 11. I've got a root password, again, super secure, all that stuff. And then I've got traffic running version 2.9. I really should upgrade this to 3.1, but here we are. I've got it right here. And I've got a couple volumes and so forth. So this is literally copy and pasted from a working, like this would have been from my local Docker Compose with a few tweaks in there. I can have it. I can have the webhook or the stack create a webhook. What that means is, again, when any of the images update, or if I have something in my workflow, that it is going to then they're going to go tell Portainer that something has changed, and it is going to go and reload that entire environment. So it's going to load everything from scratch, including any new versions, all that type stuff for you. You never have to worry about that. I can do some environmental variables, access control, all that type of stuff. I'm not going to worry about that right now, but I am going to go deploy the stack. So what is happening now? It is downloading all those containers, and then in a few moments here, we will see all that start to come alive, hopefully. Deployment in progress. All right. So it has downloaded all those images. It is currently deploying, and we'll see here that all these containers are running. So my proxy is running, my front end is running, and my database. If I go and jump into the logs of my database, we'll see that MySQL or MariaDB successfully loaded. It created the database, all that type of stuff. We'll see that, let me go back to the containers or stack. My front end is running, so hopefully, yep, I should see Lucee started here. It took about 8 seconds for this thing to load. There we go. And then I've got a front end as well. So if I go and I do HTTPS cfug2.suroot.com, of course I've got a self-signed certificate. Give it a second here. My application is running, and I actually have to do another URL so it actually starts to create some data. So here we go. So I have a container here, or a set of containers, a database, a web front end, and I've got a Lucee server here that has a database running that has all this stuff. I can go and see the live data. You'll see over here that it is currently updating in real time. There we go. That's kind of fun. But that there is essentially me taking what I was working on in my developer environment and deploying it pretty much live to a server running. In this case here, it's actually running in the cloud, but there's no difference for me essentially launching that to, could have been to a local machine I'm running in my own data center, whatever it might be. So any questions about this? And yes, Randy, if you go to that same IP address without the :8888 at the end, you can see this thing live.
That's what I was going to ask. All right, I'll check it.
Uh-huh. So anyway, while I'm in here, I can also show again that hosts. I can see. I think that's all I'm pretty much going to be seeing here is stacks, right? So stack works, all that type of stuff. If I did want to migrate this entire stack to another server, I could do that as well. I can say instead of running on server number 2, I want to run it on server number 3. I can do that, migrate. It's going to go unload all those servers and then rebuild that same setup onto a different server. So kind of nice. So if I needed to migrate an application to the cloud, that's that's an easy way to do that. Or if I need to migrate an application from Docker to Kubernetes or whatever it might be, this is a way you can do that. The only thing to note though is your volumes won't move over. So if you have a database or whatever with a whole bunch of data in it, that won't automatically move over, but the actual running applications will, and how they're configured and all that stuff will move over. So, speaking of Swarm and Kubernetes, I've been kind of dancing around this one here. So in my environment, I also have a Docker Swarm setup. So for those of you who don't know what Docker Swarm is, Docker Swarm essentially allows you to take multiple Docker servers, and essentially they can act as if they are one environment. So in this particular case here, I have a swarm that actually has 2 servers. These are the IP addresses. They are actually located in different data centers, but I can have an application that can be spanning those. I can have my database going in there. What's really neat about Swarm and really neat about, and it's almost the exact same thing with Kubernetes, is I can launch an application. I can say, hey, I want you to load a copy of this application or 5 copies of this application or whatever it might be across every machine running in the swarm. And if one of them were to fail, if a data center went offline or whatever, the load balancer just figures out which one is active and starts sending traffic to the others. It also helps with, again, load balancing applications, if you have something going on, all that type of stuff. So right now, again, I've got 2 servers here. I'm just running that Portainer agent, and I really don't have anything else going on. But I can go and launch, let's say, a container that is in that swarm. So very similar to that initial container that I had, that today application. Let me go and pull my notes on that one. So I'm going to go and add a container, but I'm adding it to that swarm. I'm going to call this today. ARM. Again, I've got my repository here. I'm going to go pull the latest image. I am going to create a webhook on this one here. I'll get into that a little bit later. Port mapping, again, this here, because I don't have a web front end or a load balancer, I need to talk directly to the Lucee server, so port 8888. I can say what node do I initially want to deploy this onto, which is just one of those 2. I could name these things. And then, of course, all the advanced container settings on there as well. So I can go deploy that. And what we're going to see here is in our container here, or in our container list, we see this new container running. Well, that's kind of cool. Actually, sorry, I did that wrong. Here, let me go remove that, because I did that as a container, but I want it actually as a service. So in the world of Docker Swarm and in the world of Kubernetes, you have a concept known as services. Services are things that, again, can be load balanced and all that type of stuff across multiple servers. So I'm going to go add a new service. We're going to call this today-swarm. I still have my tag there. It's going to be talking to the latest. I can say how many replicas of this application do I want to have running. So how many versions or copies in memory do I want running of this application? Right now, I'm only going to start with 1. I'm going to, again, map port 8888. I'm going to create that webhook, and then I'm going to go and create that service. Now, what we'll see here in a few seconds, if I go back to my cluster view, it is now launching that today swarm on this first server. Give it a few moments there. And if I go back to services, okay, it just turned green. So what this means over here is I have this running. I can go and take a look at the service logs, so I can see the logs that are on here. I can do an update of the service. So if there's a new version of it that comes out, I can hit update service, and it's going to go slowly roll that out. So it actually launches a new version. And then once that new version goes there, or once that new version launches, it's then going to go and remove the old one from memory. I can roll back, so I can go back to previous versions. I can control the number of replicas, all that type of stuff. So if I go and run that demo, so this is going to be on CFUG 4. So my application is running. Well, that's pretty cool. Yay. By the way, I don't have public IPs for those. And I can see that this is running on that one server. Well, what happens if I want to have it running on both of the servers and have load balancing and have all that type of stuff going? I can go to my service list here and I can say, right now there's currently 1 of 1 running, but I want to scale this up and I'll say I want to have 2 of these running. So over here, it says, right now there's 1 running. optimally it wants 2 of them to run. And then in about 10 seconds, we'll see that, hey, now there's 2 of them running. And I can go take a look at my list here, and I'll see that on server 1, I've got today's swarm running, and server 2, I've got today's swarm running as well. Again, I don't have a load balancer or anything like that sitting in front of this. So you're not going to see anything different, but trust me that it is running. I can hit 1 on each of the servers. And then if I, let's say, no longer wanted 2 of them running, I want to go back to 1. I can go back to here as well, where I go to the services. I can say, hey, I want to scale this back down to just 1. And then in a few moments here, we'll see on the cluster view, this one over here is going to start turning off, and then it disappears, and away we go. Now I just have 1 running. So that's pretty cool. Any questions about the swarm? And like I said, Kubernetes works very similar. Kubernetes, of course, adds an additional layer of complexity as far as the networking, as far as host utilization, all that type of stuff. But concept is pretty much the same. All right. And the last thing I wanted to show off in here as well is they also have the concept of templates. So Portainer has set up quite a few templates that exist over there for common or very popular open source applications. You'll notice that command box and content box are on here. So there is actually some CFML servers that are available on here. But you can do things like, hey, I want to do an Elasticsearch. I want to do an HTTP server, a GitLab server, Grafana, any of those types of things, and say essentially, yep, just go and launch it. So if I want to launch, let's say, a MySQL server, or let's see here. Yeah, MySQL is fine. I can go click on this here. So I can say, give it a name, MySQL server. Root password, ABC12123, enable access control, hit deploy, and it's actually, I don't then have to worry about any of the settings as far as what the container image is, any of that type of stuff. These are common templates that exist there. You can also create your own templates. When you create your own templates, what ends up happening is you define what those different variables would be that you'd be asking for. And then, so let's say it's very common for you to deploy a server that does, I don't know, prints invoices or whatever it might be, but you're always going to be deploying these things with different printer names or some, I don't know, I'm just coming up with stuff. But essentially, you can go and create your own templates, and then you can start deploying those out as well. So if I go and refresh here, containers, we should see that the MySQL server is running. And I can go and take a look at the logs, and we see that it did successfully launch. And in theory, I should be able to connect to it and so forth. So, and that is off of a template. Again, they've got a bunch of different templates out there of different open source applications. You can go through that entire list. Let's say that you really want a Node server for some reason, or a Redis server or something like that. Those are all on here as well. There's your SQL server running on there as well. So Randy, you could do that and start loading your data onto there. Like I said, and then you can do custom templates and all that. So I think that is pretty much the end of my presentation. Oh, I did want to show the pipelines. So when we set up the Docker swarm and we have a service and we have that today swarm, I have this service webhook over here. Essentially, this URL, if I were to do a post to it, and let me go and show you what it is. Over here, cfug1, suroot.com, port, API webhooks, and this entire thing right here. If I were to do a post to that command, it'll essentially relaunch, essentially pull down a brand new image and relaunch that container. This is, again, very useful. Let's say you have a workflow where after you've done a whole bunch of CI testing, so that your integration testing, you've done 1,000 tests, your application is good to go, it's got sign off from everything, you push a new registry, an image to the registry container, it can then automatically reload your application so it's always at its latest. So get out of my way here. So let me go to hub.docker.com, and hopefully I'm still logged in. I am. I got my CFUG Docker today container, and I currently have version 1.0.0 currently published. I can go and put it in a new webhook. So let's say test web hook, and I can do that URL. Now I know that this IP address or that host name won't work, so I need the IP address of this particular server, which is this. I'm going to put that in there, port 9443, hit add. So now if a new image gets posted into Docker Hub, it'll automatically go and relaunch that new version. So to show that happening, let me go into GitHub, pull up that repository, and we can go and make a change. Let's see here, go front end, my web root. I can go in here, I can go edit this file, totally what I do live. So edit this file right here. And instead of saying today is, we can say the notable things that happened today are, or for this day, notable things that happened for the day of, and then the date. So I made it just a simple change here. We're going to go commit this. I updated this. We're committing. So I can see on here that we just did a change on here. I can go and create a new release. So I'm going to go draft a new release. I'm going to go say this is version 1.0.0.1. And this is going to be release title version 1.0.0.1. And I can go and just say, yep, some stuff happened. And this is going to mark this as latest release, publish release. So in my releases, we'll see there's now 2 releases. I can see in my actions here, it is starting to build a Docker image for me, and we can actually watch this thing happen. This is it downloading the images. You'll see it's going to copy all my files there. It's doing a warm start of Lucee. It's then going to push the that new container over to Docker Hub. It has done that, and the job is now complete. So if I go back to Docker Hub and I hit refresh on here, we'll see there's now a new version. And in theory, if I go to Portainer, go to services, it is running on latest, version 77, whatever that means. Looks like it was just updated. So if I go to over here, today is, nope. Let's see here, where was that running? Sorry. I am lost. Okay, where? It is running on Swarm. And it looks like it updated, but I don't know where. Tasks. What version is actually running on this thing? see here, my containers. It says it was created and it says it's running, so why didn't this update? I don't know. So another way we can do an update on this as well, and I'll just show this really quick since the web push didn't work essentially. 18, yeah, didn't get that webhook. That's weird. Let me go and just check one thing on here. Webhooks. Test webhook. History. Oh, it did fail. So it was unable to push that out. Looks like, oh, I know why, because I don't have a valid security certificate on my copy of Portainer. So in theory, this would have done essentially this service here if I go and hit update on here. Do I want to actually update it? Yes, I do. And we'll see over here, it is currently rebuilding that it's pulling those down. It is now live. If I go pull this here, noble things for the day of, and then it's worked. So in theory, that would have happened automatically. Sorry, it didn't on here. I didn't test that, but that new version is now running. So that is all I have. Are there any more questions about any of this?
I had questions, Nick, regarding like Portainer. Nick's like, of course you do. Regarding Portainer, where is it? Is it running in the cloud? Is just a container that you loaded in your Docker to abstract and simplify the creation of containers, I think, if I'm understanding that right.
Yeah, so Portainer itself is running wherever I tell it to run. So in this case here, it is running on the server known as cfug1.suroot.com, which happens to be in MSU's data center.
Gotcha.
SU root 2 is actually running in AWS. SU root or cfug3.sroot.com is running on my server over here at home. So it doesn't matter where it's running.
Gotcha. And Docker is doing all the coordination between you have a server sitting at home, one in the data center, and Randy here trying to access your webpage.
Yes. So essentially all it itself, if I go back to environment cfug1, it essentially is its own container that is running. So it is, I can run that on any of those servers as long as it is running somewhere, it doesn't care, and that's your management interface. And then all of those agents, so those other Docker servers that are out there, they are connecting to it.
Gotcha. Okay. So I guess in our situation, why would you select? Because basically the jobs that you're doing, like right here, a good chunk, Walt and his team would do in network and computing. You see what I mean?
Yes. So this is a tool that really would be for like a Walt or like your DevOps folks more than the developer.
Okay.
But essentially, if you start going to Walt and say, hey, I want to do containers because of X, Y, and Z. It's cooler. It's more secure. It's whatever. Walt, good chance Walt, who's been running a Windows server forever on bare metal, is going to say, no, I don't want to do that command line stuff. That makes no sense. Or I don't want to run Linux or whatever. Where this essentially puts a pretty front end on all that container stuff and makes the really hard stuff a lot easier.
Gotcha. But you don't have to run it on Linux only. It will run on Windows, right? Or Mac or...
So Portainer itself runs anywhere that a container would run. I would say that probably 99% of or 95% of all the containers that are out there that are not for developer machines are going to be running on some flavor of Linux. You can technically run it on Windows based servers. You can technically run it on Mac OS. It's not something I see very common in production. Again, for developer access and all that type of stuff, it doesn't really matter because Docker is Docker. Essentially, you either have a Windows-based container kernel or you have a Linux-based one. But under the hood, that's what you got.
Gotcha. So I should be encouraging Walt and company to. I'm just trying to think of what would be, like you said, he's been running Windows Shop forever. Mm-hmm. I don't know even what spin that would put on besides it give me more flexibility.
Yeah. So, but this is where, so for example, the university as a whole has been doing more investment in DevOps culture. So they are starting to spin up like EBS and like some of our like accounting systems and things like that. They are starting to spin those up as Docker containers. And they're starting to put those into these types of environments. Right now, they are literally doing everything command line based until they start moving it into an environment like this or like, or again, Red Hat OpenShift, all that stuff. Again, Red Hat OpenShift and Tanzu and all those are very similar concepts. They just tend to be a little bit less flexible as far as, do I want to run under Docker? Do I want to run under Kubernetes? Do I want to be in the cloud? A lot of them are pretty myopic as far as where are you running your container or where are you running your containers?
Gotcha. Well, I'll let everybody else ask questions. I'm still thinking, but I mean, I'm still trying to like wrap my brain around it. I mean, I appreciate the presentation. It's for like starting, but like you said, in my situation, I got to get around network computing or get them aboard or something.
Yeah. You as a developer are probably going to be less in tune with this. Maybe you are involved a little bit with, they may give you access to say, hey, yeah, so now you've made your new version of your software. You can now do the click here and do update, and then it's going to go roll out your latest version to that application. Remember, some of the nice things about containers is you always had, like, you as a developer know exactly how things are deployed because they're deployed exactly the same way on your local machine. So how you configured the drivers, how you set up your SQL connections, how you did your code, did you copy all the files over correctly, all that stuff, all that is on you. And you just make this, pretty hard drive image that then you give to your DevOps folks to do their thing. And what they do with it doesn't really matter if they're running Portainer or if they're running on Amazon EKS. It doesn't matter because, then they're going to be doing some things like, mucking with, let's say, a load balancer or that type of stuff. But they're not going to have to worry as much about, did they copy the files over correctly? Are they running the right J2EE jar file for your MySQL connector or, that type of stuff? That becomes more of the realm of the developer. And you have complete control over those things. Because with containers, the whole thing is, if it runs on my machine, it's going to run exactly like that on the production server.
Right. Yep, still a lot to wrap my head around, especially in my current like work environment. And
yep,
I hear what you're saying, and I mean, it's kind of funny you mentioned that stuff. Like, well, they don't get into that stuff now. Pretty much all that stuff falls on me anyway. So whether if I got to do it through containers or whatever we're doing now, it's still falling on me. So. Rick's got
I
a
have
question.
something. Oh, go ahead.
Oh, Charlie. Go ahead, Charlie.
No, if Rick came up first, he's first.
Well, he's still muted.
Go ahead, Charlie. I can comment later.
You're first in my book. All right. So I just wondered if Randy or future viewers might want to see this done with a Cold Fusion container instead of a Lucee container. And I realize, Nick, you may not use them very enough to feel like you could just do it, but I can show you guys how simple it is to do and just guide you through what you need to see if you want to give it a shot real quick. It would only take a couple minutes to show it happening.
Yeah, I mean, if you have a container somewhere that I could just load up, I mean.
Yeah, so a couple things. One, go ahead and go to the containers page.
Yep.
And just click the new container button. And notice there, I just typed CF at the top, for the name. Yeah. And then notice there's that search thing. Well, if you just type Cold Fusion without even, yep. And now click the search button.
Yep.
And it takes you to I don't know if you've shown this before, but it takes you to the Docker Hub. And look, there's various Cold Fusion things, but the first one there is Adobe. Yep, so click on that. And then there's various tags if you look above that, right? Or you can do that, sure, just that's fine. Yep, and that's it. You see, all I did was copy that, and now go back into that Portainer page that you were on, and just drop it in right there. And in the future, as you do this, you'll have more and more of these in here ready to go. As soon as you type Cold Fusion, you'd see what you'd already seen. Now, if you go ahead and run that, there's really nothing else we need to do. Just for now, go ahead and run it. I just want everybody to see what'll happen.
Still 8080, right?
It doesn't even matter. We're not even going to expose ports right now, but it would be 8500 is the default port right, that CF uses for the CF admin. But it's not going to work at first, and I'll show you why. And I just want people to see why, hey, this doesn't work. So if you hop over to the view that shows them running, you should see that it says it exited. Now it's downloading, so that's why it took a moment, but it's done downloading. He's got it now. And it exited. And look, right there, it says the EULA must be accepted. So remember I said earlier, you don't need a license, but they need you to say you accept the thing that says you understand there's a EULA. So yeah, just drop that in the environment variables down at the bottom and lets everybody see that there's just an ENV tab. And you just drop in accept EULA. And it's case sensitive, so you got to get that right. And that, yes, case sensitive. And that's it. And now he's exposed that port. And when you click that, it'll replace that one that failed. And you might go, well, it's going to take a long time for this to come up. No, it's going to take 18 seconds. Not 8 seconds like Lucee, but 18 seconds. That's not so bad. And if you scroll up a little bit, you should see that button to show the times. Oh, there it is. That checkbox at the top that says show timestamps. And then everybody can see, there it is starting at, it's pretty small. I can't quite read it, 40:31. And there at the bottom, it was finished at 40:54, so there it is. It's running. And if you hop out to your browser now and say localhost :8500, you'll see the CF login. Did you say just a second?
Yeah, I just need a second here just to add that to my load balancer so I can actually get to it.
Because you're not running it on your local machine. I didn't notice that.
Yep.
Okay.
CFOG 3.
Well, and so for everybody else, if you were running Portainer on your local machine and you deployed that container on your local machine, you would just say localhost :8500 and boom, there you go. And if you might go, wait, what's that? Well, that's the built-in web server showing the folders. And if you look in CF IDE and then go to administrator, you see the administrator login, and there you go. And there's no password defined. I just want to clarify, you could pass in an environment variable that names the password. If you want to be able to get to the admin, some people would go, well, you don't want to do that. You just shouldn't be changing the configuration. And this is one of those things, Randy, you were trying to wrap your head around. When you start getting into containers, you're going to learn that, there's some things you want to do, and people will say, well, you shouldn't be doing that. And but I want to do that. And I just want to let you know that Adobe's provided for that. There's an environment variable you could pass in that would have the password. You can set it as a secret. There's ways to handle that. But now that's that. Go ahead. Did you want to say something, Nick?
Nope, no, go ahead.
So that's that. That's it. That's how easy it was done. He just was in the containers page. He used the Docker Hub search capability, found the Cold Fusion container, told it to start. In 18 seconds, it was running. You don't have to install Cold Fusion. It's not any different than what he did with Lucee. Now, he showed using a compose file. And if you go to that stacks page and create a new stack, one of the options right there was repository. Well, take a second and open your tab in your browser, because some people want to see this, even if they don't want to use Portainer. If they're using Cold Fusion with containers, they may be interested to see this. So open a tab in your browser and just Google awesome CF Compose. So there's an awesome Compose project, which is compose files for all kinds of technology. Well, a few years ago, I created this awesome CF Compose, and it's a series of projects. Yeah, just find the one that says Cold Fusion 2023 latest or CF-2023 latest. Right, so there you go. Now, what you notice, there's the compose file down there at the bottom, and it's a standalone compose file. You don't need anything else. Well, that compose file is in this repo. Any of you who get the repo could certainly just download it and run these yourself, but that Portainer capability says, well, if you point me to a GitHub repo and point me to the path of a compose file, I can just run it. And I don't know if that'll work, but if you just scroll up a little bit, at the top, you'll see there's a button that says copy path to the left. And that, sure, just up at the top now, you see straight above your mouse is the little copy button.
Yep.
About 3 inches above where you are. To the left of that.
Oh, this here.
Right there. Yeah, if you just copy that, now that's going to be the path, and you'll also need that URL to the repo. So you'll need both, but if you don't have the clipboard history on, just do one at a time. And yeah, just now in that, right, just drop that into there. The third one, put that in the third one.
Yep.
And now in the first one, just go back and get that URL. Yeah, up to there, just the part that says the name of the repo. And then that's it. And then down at the bottom, I think there's a button that, you can, again, choose the ports you want to expose, or you can choose the button that says expose them on random ports. So that part, again, we don't even need to worry about the ports. Just go ahead and deploy it.
All right, what are we missing?
Maybe the name wasn't there. Yeah, at the top. Yeah, just call it CF, And that's it. And when he runs that, it's just going to do the same thing. Now, there you go. What's it saying? Look closely. Is there maybe a missing slash or something? It should be pretty straightforward. Just what is it complaining about? Failed to deploy stack.
Someone's already running on 8500.
Oh, yeah. Well, I didn't see you. Oh, yes. In my compose file, I did tell it to expose 8500. So just choose the random ports option. It'll pick different ports, or stop that container that was running on 8500. Again, Randy and folks who get into this stuff in the future, you do have to realize you're now running two things, and if they're both on the same port, they can't both run at the same time. So if he were to stop that, I don't know if you can do that and not lose all this, but did you do whatever you thought you needed to do? And now it's ready to roll.
With this one here, it's not letting me do that. So it's.
And if you go to the containers page right now, you'll lose what you typed in, right?
Yep. Yeah.
I don't think there's a save feature, but you go ahead and do it, because it might be of value for people to see how easily you can just go to that awesome CF Compose page. And we didn't talk about it because I wanted to get it running, and then we would talk about it. But while he's getting this set up, he knows what he needs to do. He might even still have in his clipboard that repo is the current thing. Yep. And then it was, that CF 2023 / docker.yaml. It was YAML. So, yeah, just get it from there. So it's the path and the name of the YAML file. And that's that. Now it should deploy if you gave it a name. I didn't see. Yeah, you just got to remember to give it a name.
All right.
There you go. And now it's doing it. And in a moment, that thing will be done. Same thing, 18 seconds, it'll be done. And what I want to get at is that awesome CF Compose repo has lots of different examples of configuring one with a database, passing in a car file to do the CF admin settings, the new capabilities in CF 2021 and above to pass in configuration through JSON in the CF, the equivalent of CF config, which is called CF setup. So again, it's all covered, different things, calling databases, showing Redis session use, showing the Cold Fusion performance monitoring tool set. That awesome CF repo has about a dozen or 24 working compose files of various sorts. And I've got Lucee ones, and I've got Ortus command box compose files with both the Lucee Ortus command box image and the Adobe command box image. So I'm just saying, that's a place to get started. And I also point in my awesome CF Compose site, I point you to the resources from Adobe, from Lucee, and from Ortus on how to use their images. So it's a good little one-stop place to go looking. And I didn't notice, what you might have picked. Maybe you didn't expose the port, or you didn't. But it's going to work.
These domains are
there
internal
you go,
ones.
and there it is, and there it is. So he could see the admin, and you might go, well, what about my code? Well, that's a whole nother discussion. You can put your code into the container. There's a place in all three kinds of images that says where to put it, or you can create a volume and mount that folder that's on your local machine, or in some place on the web, mount that to that container to be used. And yeah, you could run your own app just like he did earlier. In fact, he could, I'm not saying you should right now because there might be some quirks about what he did, but he could run that code he ran earlier against Cold Fusion just by telling it to use a Cold Fusion image instead of a Lucee image. It does all work the same way. And yes, it's free for development. And then yes, it's requires a license for production deployment. But like you were saying earlier, sometimes people just doing it to show things work, and you could like do development on your local machine and then push it up to the production machine, and you could push the container up to production, and if production's licensed, it'll run there, and if you're on your local, it's dev and it's free. So hope that was helpful. Sorry, it took about 10 minutes.
It's all good.
That just made the presentation even better, Nick. That's what it did. Gave even that ACF perspective to it. So we appreciate it, Charlie.
You bet. A little sugar on top. Cinnamon.
Yeah, a little sugar. There we
sugar.
go. That's pretty interesting. Yeah, that's interesting. That's all I can say.
And I've got presentations on my site. I shared a link in the chat, by the way. I don't know if you noticed that earlier, Randy, but when you were asking your question about the CF images versus the Lucee images and the licensing, I shared a link in the chat to a presentation I did comparing and contrasting the Adobe, Lucee, and Ortus CF images for CF and Lucee. So that gets into that discussion. And then I've got other presentations that are introducing you to, the CF images and their environment variables. And I've got other ones on doing, the CF setup stuff for passing in JSON configuration. But anyway, let's let Nick wrap up.
Yeah. So the Portainer docs, docs.portainer.io. If you want to get into it, their docs are pretty good. They don't explain Docker concepts or Kubernetes concepts, but as far as if you understand kind of 1,000-foot view what's going on with those, they do a really good job of translating that. Portainer also has what they call their academy, so you can sign up for courses on how to deploy your application using Portainer on containers, all that type of stuff. So they've got, I think at this point, 4 video series, about 60 to 2 hours, 60 minutes, 2 hours each at the moment, and then they're doing more. They've got some more like in the works, and then of course our YouTube page at CFML for some previous presentations by myself and quite a few others. So that's pretty much all I've got. So
yeah, thanks, Nick. And I wanted to thank you, Charlie. I started to talk and I did my mic up. It did, I think Randy was right. It did add a considerable amount for people watching this on YouTube that are coming at it from an Adobe CF perspective. I'm looking at this and it's kind of, I remember coming into this 25 years ago and I never had the need for it. But if you were, looking at multiple servers, you had a heavy traffic, it was like rocket science. You almost need to bring in a consultant to get the thing running correctly. And now it's push button. I'm not saying there isn't some learning involved, but it's considerably easier to go about it. And I'm wondering, I think a couple of years from now, the AI will run the whole thing.
Yep.
Just give it some objectives and it just will go at it. Because it's abstracted enough now. You can just have commands and run things. So I think it's pretty cool.
And until then, just seeing how easily you can automate deployment, that is the crux of the power for now. And that will be powerful for people for a long time. It's definitely a valuable new capability, but it's really, new to some, it's several years old to others. But when it's new to you, you got a lot of wrapping your head around things to be done. So Randy, it's understandable that you were challenged to figure out some stuff. You'll just find as you dig into it, you'll find more and more that is well suited